Good day, learners. Today's lesson we will be dealing with chemical bonding on the section of chemistry. From today's video, you have to have learned how to draw the Lewis dot diagram to be able to determine the number of bonds an atom can make, to be able to describe the covalent bonds as shared pairs of electrons, and to be able to present different types of bond with the Lewis dot diagram. Okay, with a recap of grade 10's content, atom consists of protons which are positive in the nucleus, neutrons which are neither positive or negative in the nucleus, electrons which are negative charged and they surround the nucleus. For any particular element, there are a number of protons which is represented by the atomic number on the periodic table. For example, as I have pointed out here, we can see that we got an element, lithium, which has an atomic number of 3, which is at the top left corner. As it is like this, it indicates that protons of lithium are 3, and the third bullet here indicates that the number of protons is equal to the number of electrons. With an example to lithium, it means that number of protons is 3 and number of electrons is 3. This is the thing that you should know and know it by heart. Electrons move in orbitals around the nucleus. Orbitals have different shapes and can be found in different energies level. Then here's a picture that I've pointed out which has 3 energies level. 3 energies levels, it is indicated by these dotted lines. We have the first energies level, the second energies level, the third energies level. And on the first energies level, 1s orbital, which is only found on the first energies level. And the s orbital has the spherical shape, which is found on the first energies level, and hence as we increase the energies level, you may find that there are an increase of orbitals. On the second energies level, we may find that there would be a 2s and a 2p orbitals. And on the third energies level, we might find that there is a 3s orbital and a 3p orbital. With some addition to the knowledge is that orbitals is said to be the region in space around the nucleus where electrons are most likely to be found. With the continuation of the valence electron subsection, electrons are arranged in this orbital according to the Aufbau principle, which is as follows, and I have made an Aufbau diagram to at least give you an idea of what is an Aufbau diagram. Okay. With the first rule, it says that the electron fills the orbitals with the first lowest energies level, which it is in order of the filling orbitals as 1s, 2s, 2p, 3s, 3p, 4s. So it will fill its first orbitals like this. You can see, yeah. Okay, then the second rule, it points out that each orbital can only be filled with 2 electrons in opposite direction, like this. Can you see that the first electron is pointing up, the other electron is pointing down in one orbital? Okay. Then with the third electron, it says, with the third point, it says electrons with the same amount of energy fill individual orbitals before they pair up. With the last point, it points out the thing that it is in 2p and 3p orbitals, which means firstly, electrons would want to be freely in their space. Afterwards, they will be paired up later before they could go to the second energies level, which is firstly pairing up on individual orbitals freely. Second of all, pairing up later on to be in full. Then this is the entire complete Aufbau diagram that I just have indicated on your right hand side to have a clear picture of what to expect when they say draw an Aufbau diagram. With the last emphasis on the valence electrons, the arrangement of electrons can be presented by electron configuration, which are as follows. We have the expand notation, condensed notation, shorthand notation. I have pointed out an example which is on the element potassium. Potassium is said to have 19 protons and 19 electrons. Okay, from there, for the expand notation for the potassium element is that the expand notation, you expand every single orbitals and how many protons does it obtain or does it have inside a single block orbital. For the first orbital, we have S orbital on the first energies level, which is occupied by 2 electrons. We have on the second orbital, we have S orbital and P orbital. S orbital is occupied by 2 electrons. P orbital is occupied by 2 electrons. X, okay, and 2p x orbital is also occupied by 2 electrons. 2pz orbital is also occupied by 2 electrons. The reason why I placed the x and yz below, it's because this thing have common energy, which means they are placed in separate blocks because P orbital has 3 blocks where 6 electrons can be occupied. Okay, moving to the third energies level, we got the S orbital, which is occupied by 2 electrons. We got the px orbital, which is occupied by 2 electrons. We got the py orbital, which is occupied by the 2 electrons, and we got the pz, which is occupied by 2 electrons. And on the fourth energies level, we got an s orbital, which is occupied by 1 electron. Okay, as you can see, The expanded notation, it's more expanded, and it gives the electrons in much more details on how are they occupied on their orbitals. Then we go to condensed notation. Condensed notation, the electrons which have a common energy, they are condensed to be presented as one set. Okay, then we got the s orbital on the first energies level, which has 2 electrons. We move into the second energies level. We got the s orbital, which is occupied by the 2 electrons. We got the p orbital, which is occupied by 6 electrons. Can you see that on the expanded notation we had 3px, py, p2, which are all occupied by 2 electrons, but on the condensed notation it shows that they have been compiled to form 6 electrons which are occupied by the p orbital. Okay, moving on to the third energies level, we see that there is an s orbital which is occupied by 2 electrons. We got a p orbital which is occupied by 6 electrons. On this p orbital, it is the same scenario to the p orbital which was on the second energies level. Okay, then lastly we have the fourth energies level, which is the s orbital occupied by 1 electron. When you check these numbers that are on top, more kind of they are placed as an apostrophe. When you add all the numbers, they have to give you the total number of electrons that an element you are supposed to be presenting. Okay, then as we move to the shorthand notation, the shorthand notation is that we have to present things as core electrons, which is electrons in the inner energies level, and we have to represent them again with the valence electron. Valence electron is electrons in the outermost energies level of an atom. So here for the shorthand notation, all the core elements or electrons that will be occupied, they are all in group 8. You must know that Ag is an inner element, helium is an inner element. You should know that. Okay, having to restructure the potassium element with regards to the shorthand notation, we're gonna say Ag, which is on the 8th group, and it is said to be an core element. It has electrons which occupy the entire orbital, which are all placed fully packed. Okay, then we go on to the fourth energies level, which is the s orbital, which is occupied by 1 electron. Okay, on this scenario, when we identify the valence electron of potassium, it is on the fourth energies level, which is occupied by 1 electron. Okay, and I have reconstructed an Aufbau diagram here with regards to this potassium element, so that you do a good structure of how should you draw a Aufbau diagram. Okay, then you can see that when you have to apply the Aufbau diagram in your scenario, you have to comply with the 3 rules that I have pointed out in the previous lecture, which is very important. Without you applying those rules, you are gonna lose marks. And we have came to our last lecture slides, whereby I have provided you with an example for you to practice and check if you have the knowledge that I have shared to you. And right now, you see, the question is to provide an Aufbau diagram for an element carbon. And you should give the expand notation, the condensed notation, the shorthand notation of the carbon atom. So from now on, I'm just gonna give you 5 minutes to do the work. Okay, I hope you guys are done with the example that I've provided you. Okay, then here as we provide the answers. So, first of all, we have to ask ourselves that how many protons or electrons do carbon has? Carbon has 6 electrons, which means when we put it in an expanded notation, it's going to be on the first energies level, s orbitals is occupied by 2 electrons. On the second energies level, s2 is occupied by 2 electrons. On the second energies level, px is occupied by 1 electron. On the second energies level, again, py is occupied by the 1 electron. Can you see when we represent it on the expanded notation, it shows that they have complied with the rules of the Aufbau principle, whereby they have represented firstly the electrons freely in motion before they could pair up. So if you would have said 2px2, it would have been wrong because you did not follow the Aufbau principle rules. Moving on to the condensed notation, we have the first s orbitals, which is occupied by the 2 electrons. We have the on the second energies level, we have the s orbitals, which is occupied by the 2 electrons too. But on the condensed, it is placed in a general basis to show that these electrons have the same energy, which means they combined the first px orbital with py orbital, then combined it to make it 1, which means on the second orbital, the p orbital is occupied by 2. Okay, moving on to the short notation, it's that we have to represent these things by the eighth group, which are core elements. Remember, guys, element helium, it is the one that has um, a filled orbital which does not have a shortage of electrons. Can you see that? Okay, then as we continue, we say helium, which is the core element representing core electrons, which is occupied by 2 electrons. Then we move on to the second energy level, which is which consists of the s orbital and the p orbital. On the s orbital, we can see that it is occupied by 2 electrons, and on the p orbital, it is generally placed like that, not having to identify the blocks in the p orbital, because in p orbital we have 3 blocks which has to occupy 6 electrons, but then it just put it in general that p orbital is occupied by just 2 electrons, not showing the principle of the Aufbau diagram. But on the expanded notation, it points out that there is an Aufbau diagram principle that has been applied, which is the 2px orbital occupied by 1 electron, the 2py x, which is occupied by the 1 electron. Okay, with the structure here that you can see about the Aufbau diagram. The Aufbau diagram on the first energies level, it has been occupied. The second energies level has been occupied, not forgetting the principle of the Aufbau diagram. Oh, now we go to the second energies level, but on the p orbital. To show you what I've been saying about the expand notation. The expand notation reveals this set of Aufbau rules that electrons will be placed freely, singly first, before they could pair up and before they could even move to the next energies level. Can you see that we have one electron on its own block, 1 electron on its own block? We did not pair them already first, then we could say these people are friends already. They want to have their own space before they could be filled up. Is that correct, guys? Is that what you guys wrote? And be mindful of knowing what is required. Just don't make any assumptions of what is required. I'm gonna just show some examples of when you tackle the examination question paper. When you tackle the examination questions, first of all, highlight the keywords. They say that give, the expanded notation, which means you highlight all the keywords of the question so that you should know what is required. Don't just write for the sake of writing. So it has been written give, which means you have to give, the expand notation, the condensed notation, the shorthand notation for the carbon atom. Then afterwards, when doing this, you should ask yourself, oh, carbon atom, it is in the periodic
table. Okay, then you ask yourself, what is the symbol for carbon? Oh, the symbol for carbon is C. Let me look it from the periodic table. Okay, as I look it from the periodic table, you can see that it has an atomic number of 6, and you'll be like, oh, this it means that it has a number of protons which are 6. And since well it has number of protons which are 6, it has number of electrons which are 6. And here, just like that, they say provide, which is the key word, provide an Aufbau diagram. And you would be like, oh, what is an Aufbau diagram? Oh, an Aufbau diagram, it is a structure that shows the different energies levels with orbitals and how electrons are occupied within those orbitals. So I guess I'm done with my work here, and hope you enjoyed the video, and I thank you guys.